The next problem wants us to, or the next group of problems wants us to graph a function based upon the function of x, f of x equals x squared. So what they've given us in problems 88 and 89 are functions that are going to move around based upon a quadratic. So the basic formula for this f of x equals, there's typically an a, some sort of coefficient, x minus h squared plus k. So this k here, this is known as a vertical shift. If k is positive, we're going to shift up that amount. If k is negative, we're going to shift down that amount. That's an easy one to deal with. The h, however, is a little more tricky, but not terrible, hopefully. This is a horizontal shift. And the h itself is the value we're looking for. So in the case of 89, where we have the quantity x plus 3, that means this means h is negative 3. Because it's x minus a negative 3 will give us x plus 3. And that gives us our horizontal shift. Okay, so let's try to do, 86 or 88 should be trivial. All we have is a vertical shift of negative 1. So our graph, our original graph will look like, let's do that in black. Original graph will look like this. This is f of x equaling x squared. And a shift down of negative 1, I'll do something like this. So this is f of x equals x squared minus 1. But what to do about number 89? I'm going to rewrite number 89 in right here. All right, again, we're going to have a horizontal shift and a vertical shift in this. So here we have h is negative 3 and k equals 1. So here, if we put in a negative 3 for x, we get our 0. So we're shifting to the left by 3. And let's draw our original. All right, our original graph of f of x equaling x squared is going to look something like this. And now we need to shift up by 1 and to the left by 3. So up 1 over 3, that's where our vertice is going to be. And it's going to go up like this. And this is our g of x. Now, our vertex equals hk, where h is our x value and k is our y value. So in this case, our vertex is negative 3 and 1. And it opens up, and we can see that they're roughly the same. We just have a translation of a quadratic to get us this function.